Welcome back to the channel. My name is Samuel Barlas, and here we talk about networking and cybersecurity. Today we're going to be talking about SD-WAN, kind of defining it, what is it, when you should consider it, and why you should use it, or maybe it's not for you. But before we jump into it, any opinions in this video are my own and don't necessarily reflect any employers, past, present, or future. So just keep that in mind as we go through this. So what is SD-WAN? Really, when I was thinking of how to distill it to a very simple, short form, I came up with what has previously been ISP defined is now software defined. Typically in our control as organizational administrators, right? The network admins of the actual organization using the service, not the ISP. It gives us more control, more granularity, and typically we actually get better service because we have some better abilities to make some decisions. We'll get into that here in a few minutes. So a few of the traditional circuits we've thought about, when you think about ISP-defined WANs, you'll get something sort of like this, and I have some dollar amounts for just conversational purposes. These are going to vary based on your location, speeds, etc. Let's say we have a generic internet circuit. It's kind of a commodity, hey, internet service, about $100 a month for conversational purpose. Dedicated service, you're typically going to get a little more business class service. Let's say it's about $200 a month. MPLS or another virtual kind of network provided by your ISP, about $300 a month. And private, I mean, if we're talking dark fiber, whether it's leased or owned, that's kind of a whole different ball game, and it really varies a lot. So I didn't really want to put a number there. But if you're playing in that ball game, you know how much it costs. So anyway, we have all these different kinds of circuits. So how do we commoditize the circuits so that instead of having to pay this expensive MPLS, or maybe even pay to rent dark fiber, lease dark fiber, we can go and get some generic circuits. We can leverage those. If we're able to commoditize it, it doesn't matter which kind of service we have, then it's all the same, right? So before we get into that, what makes these services different, right? Well, this one's a lot more expensive than this one. So what defines that? And there's a few things, but the most important thing typically is going to be SLA, right? So how long before they respond, how long before they resolve an issue. There's different things within an SLA, but let's just say response time for the example. Let's say the MPLS response time is 15 minutes. Let's say the dedicated is 1 hour and say generic is 6 hours, right? So you start to see where the value of MPLS is, right? Hey, we're going to get a response within 15 minutes. Not only that, this traffic goes site to site. It doesn't go out to the internet. So there's added security because we're not going through so many different ISPs. We're only going through our own ISP. So there is some security benefit there too. I'm not going to get too much. There's some other technical details of the differences. And of course, we can go into that in a later video if we need to. For the sake of this discussion, we're going to stop there. So how do we take these metrics, these things, and put them into software so that we can define them instead of the ISP defining them with their service levels? So before we get into that too much, I want to talk about two different categories that I think about when I think of SD-WAN, because I've had very, very different conversations with different organizations that are doing things a little bit differently. So depending on where your data is, depending on where your services are, typically they're going to be on-prem or cloud. So on-prem, we're going site to site. We typically talk about technologies like IPsec, which we'll talk about a lot in this video. There's other things, ADVPN. Maybe we're talking about like a hub and spoke or full mesh topologies for our IPsec VPNs. Maybe we're doing GRE over IPsec. There's a lot of different options we have here. For sake of this conversation, we're going to keep it high level, site to site. We're probably using IPsec. We're able to leverage SD-WAN in conjunction with IPsec to provide that security that we would get from something like an MPLS link. And I'm getting a little ahead of myself. I'm going to move to cloud before I say all my material before I get there. With the cloud, maybe we're just doing that monitoring, we're looking at things. We're sending the data to the cloud though, so we typically don't necessarily have to rely on IPsec. So it's going to be a little bit of a different conversation. We're talking on-prem. We really need to worry about IPsec performance because if we're replacing, say, an MPLS link, we need that layer of security, right? So we're going to be looking at how fast can we encrypt IPsec, how much throughput can we get with IPsec enabled. So it's an important metric to think about if you're going from an MPLS network to something kind of generic and commoditized. Whereas cloud, we're typically more talking about an on-ramp situation. And we'll talk more in technical detail of what that means, but we're able to leverage some SD-WAN technologies in order to make our cloud experience a little bit better. Maybe for a particular application or two, typically not all of our applications, just a few that are mission critical. So the objectives that we're going to replace to commoditize all these links are really going to come down to two things. The first thing is pretty simple when it comes down to security. We talked about this. Got a little ahead of myself. Really, IPsec is what we're worried about there. Because typically, what we talk about when we talk about security, we're moving from MPLS, we're going to internet circuit, we're going to go over potentially multiple internet providers because we're commoditizing this. This is no longer provider dependent, right? So it could be Comcast one place, AT&T another place, whoever, right? I just said them because they're pretty much all around the US for the most part. But so now we can leverage IPsec instead of leveraging MPLS, provide that layer of security. Some people aren't going to trust their MPLS provider or going to have other kind of requirements where they have to encrypt it anyway. So it might make more sense to just go with a generic because you have to anyway, whether it's MPLS or over the internet. The other objective that previously was ISP defined that we're going to take out and define it ourselves with SD-WAN in our software is going to be our SLAs. Right? So this important metric here that really is the big difference between these circuits in most cases in terms of the organizational objective. We're going to take that SLA and that really is two parts. It's monitoring, which is very important, but also failover. Right? So if we monitor it and we see it go down and we do nothing, it's not super valuable. The value is in the failover, right? We have the ability, maybe the SLA is 6 hours, but we've got a secondary circuit we can fail over to and use while we're waiting on that, primary ISP to fix whatever is going on there. Maybe we'll have dedicated as the primary and just have a backup that's generic. That way we can have, roughly the same cost as one MPLS link, and we can have the ability to have two. What are the chances both of them have issues at the same time? Assuming they're different carriers, right? Typically we use different carriers when we're using multiple links. So, those are all things to consider. We can always keep an MPLS link and use that in our SD-WAN as well, right? We're commoditizing, so even if it's private fiber, we can use that with SD-WAN. We can test and test and monitor with the metrics I'll talk about in just a second. We can monitor those metrics on dark fiber. And if we're having some sort of issue with our dark fiber, maybe the ends are dirty, something else is going on, there's a fiber cut, we can monitor and fail that over to maybe a commodity generic link. If we already have the dark fiber and we own it, it's typically not really a huge cost. There's a little bit of maintenance cost, but in comparison, it's not terrible. So, okay, jumping down to the monitoring, what does it really mean? So we have a few things we monitor: packet loss, latency, and jitter. Now, packet loss pretty much affects everything, so probably want to fail over between links completely. We're talking about packet loss. Latency and jitter are a little bit different though, because if we're loading a web page, if we're downloading something from SharePoint, latency isn't a huge deal. Jitter isn't really a big deal at all. But if we're doing something like voice over IP, right, we're having a Teams or a Zoom call, that latency and jitter is going to matter a lot more. So maybe we're going to use our SD-WAN to fail over a particular application. Maybe our primary circuit is having some issues with latency and jitter, but our backup circuit, maybe we've cut cost even more and got a slower link that's generic that we can just send our Teams, Zoom, other voice traffic, maybe internal voice over IP system over the backup link, while our generic link's having some issues, but maybe we're not actually losing packets, or we're not losing enough to really worry about. So we can leverage, using SharePoint and other kind of heavier applications that aren't so latency intensive over that link that's having some issues. So we can not only monitor, but also fail over by application. Very, very important because we're able to leverage circuits as we need them. With what metrics is important to that application may not be important to the other application. You can also use it for load balancing, right? So we can have, some services go to our main link, some services go to our backup link. When I was a customer, on the customer side, I was running a network, and I made the decision to actually move all my guest traffic onto a generic internet link, right? So, hey, we have guest Wi-Fi. The guest Wi-Fi just goes directly onto the internet. That way, we had some MPLS links. We're not using the expensive MPLS bandwidth to send that back to a hub site. We're just going to shoot it out the generic internet service that we typically don't use unless there's a DR scenario, right? So if we typically don't use it, let's just throw the guest network over there, and we'll send it all there. Then that generic network went down, and since I had manually set it to go there all the time, guest network went down, which is okay. I knew the generic circuit was down. I digress. Anyway, so there's a few other technologies that we can use when we're talking about SLA. That's beyond the monitoring and failover. So we can do a packet duplication as well. So when we're talking about packet duplication, we're able to use both, or more than two links to send the same packet. Now we have to have some sort of node on both ends. Now in some SD-WAN scenarios, there may be this provided as a service, so you may not see the other end, but there is something at both ends to duplicate and then deduplicate those packets. So this is really helpful when we talk about cloud on-ramping. So if we're using something like Teams, maybe we're deploying a cloud on-ramp in Azure. So we're able to use packet duplication, duplicate, dedupe all those packets so that we know our Teams calls, regardless of the microsecond issues that we're having, the microsecond failover that we typically get from SD-WAN solutions. We should have a sub-second failover. We're still able to keep all that Teams traffic super smooth, and no one is the wiser except for those IT people who get those alerts. Hey, it's down. We also have forward error correction, or FEC. That's another option you have to where you can resend packets from the firewall's perspective, or the SD-WAN solutions perspective. I say firewall because usually when I talk about SD-WAN, I talk about it built into the FortiGate firewall. I'm talking about it a little more generically now, but I slip up every once in a while. So that's kind of SD-WAN as a whole. Kind of to wrap it up, to summarize it all, we're really taking what's previously been ISP defined by these different classes of service, and now we're putting this into software. We're giving ourselves control over it. We can fail over by application, a lot more flexibility there. And we're able to save money while also typically improving our uptime as well. So I'd like to thank you for viewing. Go check out some more videos on my channel if you are interested, and I'll see you in the next one.